Hi everyone. Thanks again for giving me this opportunity to talk about Rust program, how we can use this Rust programming to build automation, enterprise level automation using this Rust programming language. We'll also see as a technical exploration. We'll also see how how we can build Rust based AI solutions for transforming operational processes across the industries through high performance and memory safe implementation and architecture. Yeah. Hi everyone. Thanks again for giving me this opportunity to talk about Rust program, how we can use this Rust programming to build automation, enterprise level automation using this Rust programming language. We'll also see as a technical exploration. We'll also see how we can build Rust based AI solutions for transforming operational processes across the industries through high performance and memory safe implementation and architectures. As Rust is a memory safe programming language, and we'll go through like how it is advantages for and advantages and why it is very useful for, or why it plays a very crucial role for building AI based applications. As we know, Rust is a programming language that is perfect for building this AI Copilot because it gives us three main advantages. First one, it keeps our system safe from memory errors so that they don't crash or behave unpredictably, and it does not it does not slow down during any processes or any high level throughput, right? It never slows down. That is the biggest advantage. And the second thing, it lets the huge amount of data to process at a time and without any problems and without any race conditions, and that means everything stays accurate and everything stays under a heavy load. That is the biggest advantage. And the third thing is it allows to build complex features without any extra performance cost. And in short, Rust helps us to make sure AI systems that are fast and safe and reliable. So when we look at the Rust programming, right, as we know, Rust is becoming more and more popular these days, and Rust is becoming a popular language or favorite language for many programmers. As we know, it's a memory safe and it's a low level code programming, right? And earlier this in future, Rust might replace C++ or any other low level system programming in might future. We these days we see a lot of Rust stations, right? Let us see how Rust can be utilized for building this Copilot or AI based application, enterprise level applications, and how we can use the biggest features of Rust and why it is advantageous. We'll cover all of that. And Rust is a modern programming language that is becoming a favorite for becoming favorite for many developers these days, right? Like the main advantage, the main reason for it is first one is it's a memory safe. That means without slowing down the process, it can handle many operations. And also in many other languages, right? If you see memory errors and bugs that cause errors and that cause crashes, Rust is designed to prevent all of that. That is the biggest advantage. It's a memory safe. Any errors related to memory or any errors related to that are causing crashes, right, that can be avoided. That is the biggest advantage. And it will also prevent these errors without adding any runtime cost. So that is one more advantage. And coming to the second advantage, right, why it is called fearless concurrency. It simply means like a lot of tasks can be handled at a time, like multi-threading, basically multi-threading. When it comes to Rust, can handle this multi-threading very simply and very easily. Massive sets, right? Like for example, multi-threading or multi-processing processes, right? Like handling massive data sets or handling thousands of transactions or updating hundreds of systems at a time or without creating data mix-ups or conflicts. For example, if in a traditional programming to handle thousands of transactions at a time, it will be very complex for us. With if you are going a high-level programming language like Java or C Sharp, it will be a very tedious job to handle. But when it comes to Rust, by default, that has that mechanism at the root level, it is very easy for us to handle multi-level threading, multi-level processes. Especially, this is helping. This can help us in banking sector or financial domain because there will be millions of transactions per second, right? So that's why Rust is a favorite language for building the blockchain technologies, which has lakhs of transactions, 100,000 transactions per minute. And third advantage, right? Zero cost abstractions. We can build complex automation logic like decision making engines or real time analytics without slowing down the systems. For example, as right, like when we are building the analytic systems like BI reports, visualizations, like when it is processing huge data loads to give the reports or to show the analytics or to show the graphs, right? We encounter a lot of issues. Those kind of challenges we can fix using this Rust program language, which is one of the biggest advantage. So we put all together, right? Let us create let us create this AI copilots using this REST programming language. How we can Let us see how we can create this AI copilots or AI safe application, right? AI applications using this REST program, which can handle these high workloads and run without crashes, deliver results instantly, which exactly what industry like finance, retail, and manufacturing and other utility companies are looking for. Let us look at in the other slide. Let us look at the main building blocks that make the AI Copilot work. First, we have the data extraction engine. This is the system eyes and ears. It collects all the information from different data sources like spreadsheets, documents, databases, or even for older file formats. It works fast and it can process multiple streams at once and does not waste the memory. As we know, we can use this. We can use it can process as I mentioned, right? It can process any kind of files. Like it does not have any limits, right? It can process CSV file, audio file, or wave file, or any kind of file it can be processing. And the next comes is the agent system. This is like a brain of Copilot. It uses the AI models to understand the data and make decisions, and it can also coordinate the task. It can even roll back actions if something goes wrong, and it can adapt to based on the context. And basically, this is a context-aware system. It understands what exactly it is working on, what exactly the user is asking, and what it can respond to. And even it can handle task automation, right? It can perform some task like if there is a prompt that cannot want to execute any task, right? That can be handled by this agent system. This is like a brain that handles all the instructions. The main core logic is present here. The final one is the integration layer. As we know, this is the integration layer which is used to connect to the different system like AI Copilot. If you want to integrate the AI Copilot with the other integration systems, right? Even though it's a modern or legacy system, modern system that has API, or the legacy system which does not have any APIs, it can work seamlessly and it can integrate with the other systems safely and accurately. And these three major parts of this Copilot, the major three parts, the data engine, AI brain, and the integration layer, they work together to make the whole automation system much more reliable and fast and easy to connect, especially in the industry environment, especially where there are thousands of transactions, right? For example, a financial industry or a retail industry which has thousands of transactions per second, especially this is ideal in those worlds. We'll look at those examples in the next slide. We'll cover all of those use cases, real-time use cases, in the upcoming slides. Yeah. One of the best things about using Rust for Copilot is that we don't have to keep reinventing the whole wheel again. Once it is built like a component, like a data parser or a reporting tool or a decision making model, we can reuse it for a different project. It's like a module, like how we use the DLL files in C# or regular programming language, right? We can use it. Like if we build one application, it can be reused. Any component can be imported or referenced into another project and reused again. This is possible because the Rust has very strong type system and it's a modular design. In simple terms, it means the code is like a building blocks. It can fit together perfectly. Even they are used in different business areas where we can create generic versions of tools and then customize them, right? For example, we are building. For example, I can give you for example, we built a small POS system or a small application that's for a finance application. It can be modularized, or it can be customized, or it can be configured for other industry. For example, we built it for finance and it can be configured for other industry also, or or healthcare or retail domain or other domain also. It can be modular, as we know, right? ERP, like if we are building an ERP system like SAP using Rust, it can be modularized. If we have 10 features that we build for this ERP system, and one company they want to use only five, and out of that five, and other company they want only three, it can be easily customized. As I mentioned, these are like a building blocks. The way the Rust is built, the programming language is built, right? It's like a building blocks. It can fit all of them perfectly. That makes the Rust programming very seamless and work, and everything, all the components work together. And biggest benefit is compile time guarantees. That means system checks everything before even it runs. So If something does not match, we watch it clearly instead of finding out later in production. If even during the compile time only, all the errors are checked, because in traditional programming or in the current programming world, like usually we see a lot of production bugs. Usually, some of the issues we encounter them only when we go to production. Those kind of issues can be analyzed and understood even before during the compilation phase if we are using the Rust program. This reusability has a huge impact on time and cost. In real world programs, real world projects, like companies have seen like 60 to 75% reduction of development time for new automation workflows after they have reinvested once in Rust. As well, especially Rust, right? As I mentioned, like you say, it's a system friendly language and low level project. And there are many frameworks that uses this low code framework for building Rust. There are on top of Rust, right? They have built subsets. Basically, these are like subsets of basically the low code versions. If we are planning to build any workflows, right, we can utilize these workflows for building any workflows like workflow engines or workflows, especially business process automation. If you want to automate millions of transactions, or if you want to doing any data pipeline or data orchestration jobs, right, we can leverage this Rust programming language, which is very flexible for building those kind of operations. So instead of spending weeks and building weeks and months on spend building using these legacy applications, legacy programming languages for development, right? We can adapt to these. Even we have seen, as I mentioned earlier, like we have seen a 60 to 75% of reduction in development time for many companies which started to use this Rust programming. And fewer bugs, right? Major advantage is it has faster delivery, which is faster delivery, fewer bugs, main consistency, more consistent quality, and quality across consistent. If we are using Rust as a main core programming language for entire organization, right? As I mentioned earlier, we can reuse these components. One, like if it is developed once, it can be reused anywhere. Let us look at how this works in real time world, especially with starting with financial services. One common example is loan processing and automation. In the finance industry, right, the speed and accuracy is everything, and it can make mistakes also. It can lead to compliance issues or financial loss. Especially if we are using with Rust powered AI Copilot, can handle these thousands of transactions at a time, right? Checking documents, verifying information, making sure everything meets the strict regulatory rules and all the validations, right? If we are going with this Rust, this can be solved very easily because Rust is a memory safe. It is ideal for handling sensitive data like personal details, income statements, or credit reports, or even without making any leaks or errors. In practical world, right, like we have seen document extraction has only 99.9% accurate, which means almost no mistakes. I have seen applications, right, which uses Rust for document extraction, or OCR, right, which are very accurate, which that uses Rust programming language, which are very accurate compared to the traditional systems. The system also validates almost all the information, even it's real time, and so the approvals or rejections can happen very quickly. So if you go with the legacy applications or traditional applications, right, it is the process, like a process of doing the OCR process is handled by one system, and approvals is handled by another system, and basically the pre-process is handled by the one system, and post-process is handled by another system. But when it comes to Rust, everything can be handled together because it can support any kind of application. Like, we can build any kind of applications using this. And moreover, we can integrate, for example, we are building only the core processing system in Rust, and we want to integrate Office 365 or Power Platform, which has all the built-in approval systems, right? We can easily integrate this Rust. So one part will be in Rust, the major core part, the analysis part will be in Rust, and the approval part will be in the other systems like Power Platform. And because Rust is a very high performance system that usually runs smoothly even during the peak times, while hundreds of applications are in single hour. That means there is no delay to the customers and no backlog for the bank. And as we know, Rust, it perform compared to, if you see the benchmarks of a traditional programming like a Java based application or a .NET based application, with Rust, it's a low level program. It can perform very high compared to high. It has very high benchmarks in terms of performance. That helps us, especially during the high times, right? We have seen, especially in the banking sector, sometimes the systems might go down because of the huge transaction, especially, for example, if you take the trading world, sometimes systems might crash or systems might slow down. This can be used, this REST programming language can be used in such scenarios to handle very vast loads, especially without handling the crashes and handling those, especially during the peak times. In short, in finance, Rust-powered copilots can deliver perfect mix of accuracy, speed, and accuracy at the which exactly is needed by the current finance sector. Let us look at the industry applications, second industry application like in retail sector, how this Rust-based copilot, AI copilot can be used for in retail industry. In retail, timing and accuracy are critical because every small delays can lead to empty shelves or missed sales. A Rust-powered AI copilot can completely transform real-time inventory management. It can handle distributed updates, meaning that means it can keep track of stocks or across the hundreds of stores at the same time without risk of two systems overwriting each other. And this is possible because Rust has a concurrency feature that lets the processes of multiple stores handled and updates safely in a parallel. On top of that, right, AI, we can use AI for analyzing the sales data and trends in parallel and make the predictive ordering or predictive suggestions. Basically, this is like supply chain. For example, if you take in certain terms, in certain items, right, in certain items are selling faster than expected, the system can recommend of ordering of those items even before it ran out, and it does instantly, no matter how large the data set is. It can process the data set and it can give us the predictive results. Another big advantage is legacy POS integration. As we know, right, most of the stores still use the legacy POS, point of sale systems. Many retailers still use those systems, and most of them does not have the APIs, right? Like it cannot. It's not. They are not like IoT, which can be integrated with internet, or does not have any internet connection, or it does not have any APIs. We can build an integration layer we can build this integration layer with those legacy systems using this rest, which can translate regular transactional data or with POS data into extract the data into this our rest based online system and do performance and do analysis on top of that. As a result, right, as we know, we can work on legacy systems. It can be integrated with legacy systems. It can both parallelly do supply chain management and predictive analytics and real time operations, right? This makes Rust based AI applications or Rust based applications a best fit for retail world. Now let's talk about the manufacturing and the utilities, the two sectors where downtime and inefficiency can be extremely costly. In manufacturing, a rest about AI Copilot can automate procurement and supply coordination. It can manage real-time orders or optimization. Example: It can check the supplier availability, compare the prices, placing orders in parallel without slowing down. It can perform even negotiations also. Even it can perform negotiations with multiple suppliers. At the same time, it can ensure right quality or right quality, and also control the documents and automatically process those documents or process the communication. Like whatever communication that happens during these processes, right, that can be handled by the same system itself. We need not rely on the other systems. Especially, we have seen situations where for supply chain management, they are using one system, and for the other process, sales and coordination, they are using outreach, they are using a different systems, right? Two different systems. Those can be avoided if we are going with this Rust based approach. Rust can replace those kind of sessions. For example, in utilities, in let us take the utilities world. In utilities, many companies rely on old infrastructure like SCADA systems, like older systems like SCADA systems. Rust integration layer allows us to extend the system this by without replacing them. We can directly integrate them, as I mentioned in the earlier, right? Like even legacy systems can be integrated with Rust system. That means without zero disruptions to operations, like without having disturbing the existing operations, right? We can integrate, we can bring this into our ecosystem. We can add fault tolerance monitoring that keeps working even if part of the system fails. As I mentioned, right, this is a modular system. Even though some part of it fails, but the remaining part of it still can continue working. We can automate regulatory reporting for the compliance teams. Can don't have to spend hours gathering the data. So by default, as most of the modern enterprise applications have the reporting or log or transactional logs capability, right? The same way we can implement those kind of system which can which can capture all the logs and all the transactions that are happening on these systems, especially during the audit. When the audit happens, right? If you want to see like why what happened and all that, instead of the audit team spending hours and hours of time on understanding the data, analyzing the data, right? We can use this output as well. We can save a lot of time for audit teams. The final key benefit of using Rust is it can handle large complex operations predictably, whether it is monitoring thousands of meters in a power grid or coordinating suppliers across countries, or the system remains fast and safe, reliable, and without any downtime. Now we have seen a couple of use cases, especially in the utility world, finance world, and supply chain world. Right now, let us look at the numbers, like how Rust is compared, like Rust can perform compared to other traditional approaches. First is the memory usage. Rust's ownership model means it uses about 30% less memory compared to the regular or typical systems. That is important because it allows us to run same workloads on cost efficient infrastructure. Second one is a processing speed. In real world testing, Rust can perform data intensive operations up to 5 times faster than compared to conventional platforms. This is a huge boost when you are working on high volume transactions or real world analytics. And the third one is concurrency and efficiency. Rust can handle a parallel task up to 200% more efficiently without risk of data corruption or race conditions. This especially this is very critical in industries where multiple systems are updating the same data at the same time, especially in the finance world. These performance gains are just theoretical. They translate into faster operations and lower the costs, and also a smoother experience for both internal teams as well as the end customers. So beyond the raw performance, Rust also delivers strong business and developer benefits. First one, let us look at the first one: computational efficiency with zero overhead abstractions and a smart memory model. Rust can give us up to near C level performance, C programming level performance, while it is being safe in practice. In practice, this means the 80% reduction in infrastructure requirements, fewer servers, fewer low cloud costs, and predictable latency even when workloads changes. Plus, also there is no garbage collection and pauses slow, and there is no garbage collection which improves performance drastically. Next one is the developer productivity. Even though Rust has a big learning curve, once team gets familiar with the Rust programming, it saves a lot of time. We have seen 65% less debugging time because compiler catches many errors before the program runs. The cargo ecosystem manages dependencies that makes our developer life easy, and the documentation and the tooling are very excellent. As we know, right, Rust is evolving so much these days. There are a lot of resources for learning, and it evolves so much. There are a lot of resources or a lot of tutorials available on web, where once the team gets familiar with this Rust program, it will be very easy for us to implement this. Finally, infrastructure consolidation. Instead of maintaining multiple specialized systems, a single Rust code base can replace all of them. As we know, right, industries tend to use different programming languages. Because of that, they have to maintain different systems, like, for example, Java based system, or Linux based system, or Windows based system. All of this, that can be this it can run on any kind of system. Infrastructure wise, we can eliminate those kind of limitations. That means unified monitoring, consistent development patterns, or the consistent, and makes the audit simple and fewer moving parts and fewer to manage. And management wise, right, IT infrastructure, since it is very hard to maintain different systems for different applications which run on different ecosystems. So Rust makes that, if we replace those systems with Rust, it can resolve those kind of infrastructure or maintainability problem. So Rust isn't safe. It also reduces operational costs, speeds up development, and makes the system easier to maintain. And in long term, it saves a lot of cost for the companies. Yeah. Now let's talk about how we can implement this Rust for AI automation. Generally, we follow a few proven design patterns that make our system both powerful and maintainable. For example, the actor model. For example, actor model that lets different parts of the system run independently and talk to each other without stepping on each other's data. But this is perfect for complex workflows. And next one is the type state pattern, which helps us to lock the correct order or the step at the compile time, which so we can't accidentally run the process in the wrong sequence. And the third one is command pattern, which is useful for operations that might need to underdone. Packages each task so we can roll back it when it is needed. And another one is repository pattern. Repository pattern extracts how we can store and retrieve the data, making it easy to switch the databases or backends without rewriting the logic. As we use feature flags to enable or disable the features and the deployment time, which is great for testing the gradual rollouts. We can also leverage the powerful tools from Rust ecosystem like Tokyo for handling a lot of tasks at once, and Saturday for working with different data formats, Rustbelt, which is a natural language processing, and Rayon for parallel data processing, and Tonic for gRPC based communication. By combining all these data patterns, the known data patterns, and the right tools, we can build automation systems very easily that are not only fast but also safe and reliable, and which are flexible and adaptable. Let us wrap up the key takeaways from everything we have covered till now. First one is by investing in Rust-based automation framework, organizations can save up to 60 to 75% reduction in development time for new workflows. And that is because once the core components are built, they can be reused across all the other projects and other departments. Second is memory safety and predictable performance that can lead to 89% of reduction in production incidents. That means fewer crashes, fewer bugs, and more firefighting for the development operation in terms. Third one is the overall process times. Overall process time can be improved by an average of 83%, which is directly translates into faster service delivery, faster services and faster deliveries, better customer experiences, and higher efficiency. So the message is simple. Rust gives you fast, safe, and reliable automation that can work across industries. It's a foundation that balances innovation and reliability, and it's a proven to real world that the results in performance, cost savings, and quality. For giving me this opportunity to talk about how we can leverage this Rust programming for building AI based Copilot. Now, next steps. Coming to next steps, rather like the final conclusion, I want to say the first step is to evaluate your current automation challenges and see where the performance, reliability, or scalability are critical pain points. These areas are where we can fit the rest and show the biggest impact. Next is to consider the starting a pilot project. Choose the process that is important for your organization, something where failure isn't an option, and test Rest powered AI Copilot platforms over there. And from there, you can expand gradually, reusing these components you have built in your pilot and to speed up the future projects. Once this is over, right, you can benefit faster development, fewer issues, and more consistent results. The goal isn't to replace everything overnight, but it is about building the solid foundation where future proof of your automation. Given you the performance, safety, and flexibility you need to stay